Hey, hi guys. So in this video, I'm going to discuss about the LLD of alarm or alert service for AWS. Let's go through the feature required for this. So one basic thing is that we should be able to create the or manage the alarm for the metrics. For example, let's say if the CPU usage is going above 20%, 80%, or if the memory is going above 80%, 20%, whatever. So we should be able to configure the alarm based on the metrics of the services. It could be CPU, it could be EC2, it could be SQS. For example, like what if SQS messages are more than 1000 and all those things. So alarm can be for all those kinds of things. It should be able to support recurring or one time alarms. That is the thing. Other thing is multi-metric monitor. So basically it's more about the composite alarm. So when you are creating the alarm, either you can say, hey, if CPU is above 80%, uh, kind of send the email or call or whatever, trigger the alarm. Here what we want is we want to have a multi-metric monitoring. Basically, alarm should be based on the multiple conditions. Hey, if CPU is going above 80% plus memory is also going above 80%, then only trigger the alarm and all those things basically. Notification mechanism, so we should be the alarm should be able to notify the configured user via multiple ways. It could be email, it can be SMS push notifications, or it should be able to even configure with the SNS also, AWS SNS also. State management, again the same thing, like maintaining the states for the alarm. The next thing is the custom action, allow user to specify the action when alarm triggers. So basically, whenever an alarm is getting triggered, do we want any action to be triggered? For example, let's say the CPU usage is going above 80% and your memory is going also going above 80%. So in that case, what you would do? Just sending the alarm will not make sense enough. I mean, the users are going to suffer because of the high memory issues or high CPU usages. So what action item we can be taken there is maybe increase the uh, add one more EC2 instance to the fleet. So we should be able to kind of configure those kinds of actions. Persistence, just a basic thing, storing the alarm configurations into the DynamoDB, or maybe in any other kind of a database which is persistent. Scalability, basically supporting the high making sure that we are the latency is very low to trigger the alarms. For example, they should be very granular. Like once we see, hey, the CPU went above 80%, the memory go, it should be like trigger instantaneously. There should be uh, as less delay as possible for that. Now the let's see the solution. Let's see the design pattern which we can use for this solution. So here we are initially going to focus mostly on the LLD patterns and the single threading. We are not going to discuss about the multi-threading initially. After covering this one, we will come to the multi-threading issues and we will try to cover those. Let's first go to the basic pattern which we are using here. The one is the observer pattern. It's just about notifying the user. It's used for the notification mechanism to send the emails or to whatever to do any kind of a notification required. It can be notifying the multiple subscriber, it can be even notifying the action triggers basically. Next thing is about the builder pattern. This very common thing. We are since we are creating the alarm, and alarm configuration can be different, it can be a little bit of complex, so we are going to use the builder pattern for creating the alarm configuration. State pattern as usual, because we are going to manage the alarm state. Strategy pattern is used for evaluating the alarm conditions with different algorithm. Let's say you want to use the AND with the different conditions over and all those things. Repository pattern is just about keeping the storage about the alarm configurations which we have stored into the database. So for us, like the source of truth would be repository pattern. Inside that, we can kind of pull the database. Singleton pattern is used for Here to have making sure that there is only a single source of truth for the notification manager. There should not be deduplication notification. Not there should be no multiple alarms getting triggered at the LLD level. At only single machine level. Also, making sure that the states are managed by only single instance. Otherwise, it could lead to the issues. Basic algorithm which we can be thought here is this threshold evaluation algorithm, composite condition evaluation. We are not going to cover this. This was just mentioned here. Now let's go to the code, how the code looks like. So the code which we are kind of currently going through, as it is mentioned here, it's a single thread that does not utilize the full potential of the multiple cores and all those things. Now let's go to the, so this is just the same thing. This thing is just the same thing here. I have just opened it separately. Now let's try to see how the structure looks like. So if we see here, if I zoom it more, we have a subscriber, and under that we have a multiple kind of subscriber, which is email subscriber, SNS subscriber. There could be multi other subscriber also, which is like kind of a, you can say, action triggered subscriber or action subscriber. So that if there is any action which needs to be taken based on the notification which we get from the subscriber, then it can be also done. The next thing is the alarm. We have the alarm, which is the base class, and then we are having the metric alarm with the alarm builder, as we have already discussed. So this is just like a simple structure. Let's go to the code. Again, the subscriber is very basic. Observer pattern is getting used here. We are having this email subscriber, which is implementing this base class, and there's SNS subscriber. Then we have alarm. This is the basic interface of the alarm. Then we have extended it to create a metric alarm. Here, if you see, it's very basic. This is where we are using the observer pattern here. If you see, we are registering all the subscribers here, so that if any of the metric alarm gets triggered, you can just go and not start notifying the subscribers. The next thing is the alarm builder, where we are using the builder pattern. Nothing much different. It's just a basic builder pattern which you are using. If you are going to use some Lombok libraries and all those things, so you can do it other way also, based just on top of the class directly. So the main method is just to show you how this code is actually going to work. Just a sample use case. I know there are multiple things which we have not implemented here, but the full solutions are covered in our course. For example, there could be action triggers like, hey, I want to increase the EC2 server into the fleet whenever the CPU or the RAM goes above 80%. So how we are going to describe it, or how we are going to kind of implement this. All those things are we are covering in our course completely. So this persistence is again same thing we are covering in our course. All the other things. Now let's go through the issues which we have with this method, with this code. So here, if we see current behavior, the service handle one task, notifying the subscriber, evaluating the alarm condition at a time. All the operations are running on the main threads, resulting in the under CPU cores and all those things. Notification alarm. So whatever you have seen here in the code, it seems this code is very simple. There is no usage of the threading here. For example, just a basic thing. If we start with, if I say we have something called metric alarm here, where we are notifying all the subscribers. Here we could have used multi-threading to make sure that we are parallelizing the notification of the thread instead of going with the sequential thing. So these are the basic issues which we have in our code. For example, there could be other things which can be improved here. Like we are having this. If we talk about, since all the classes are more central to this one, here we are having state. What if the state is getting we don't see any atomic here? What if the states are, since let's say if we start using the multiple threads on the subscriber, how it will impact the states? I mean, let's say multiple threads are trying to update the states, all those things. Basically what I'm trying to say is we need to optimize this code for the multi-threading system. This looks very simple. It's like entire thing is just running on one main thread. So this is going to be a blocker bottleneck later on. That's the basic theory about like what we can do here. For example, one of the things which I mentioned is notification can be paralleled. EC2 instance with multiple core can handle. So whenever we are writing the code for these alarms and all those things, we can make sure we are using multiple cores very efficiently by writing the multiple threading, making sure that seeing if we can run the parallel threads or we need to run the concurrent threads and all those things. So one of the way we have described here already, like how we are going to use the multi-threading. If we see here is we are going to use the executor for parallel execution of the task. Now let's see what is that. So this is the notification manager which we have. Okay, this is I think a new class which we have created. So here if you see we have created a executor service. Hey, this is just initialization. Whenever a notify subscriber is getting called, a thread is kind of that execution of the sending notification to the customer is passed on to this thread basically. Just give me a second. This one, yeah. If you see in this one, executor service dot submit. So this is like saying that hey, we are uh, we are uh, we are submitting a task to the executor thread pool, which is a pool of the threads where if the threads are free, they will start they will take this task and start executing it basically. So this way we are make, let's say the thread pool size is of 10. That means we can send the 10 notifications parallelly and like why and it's going to be way faster and the quicker responses basically. So this is one of the optimizations which has been done here. Use separate thread to evaluate the alarm for different metrics. So if we go here, just give me a second. Okay, so regarding the concurrent alarm evaluation, the code is not present in this one. That is also again covered in our course. You can find out the link here already. But if we talk about what do we mean by this concurrent alarm evaluation, use separate thread to evaluate the alarm for different metrics or condition. Consider that a alarm can have 5 or 10 things to checked, and all of those can be kind of a network call, or they can be either a higher processing task. Instead of doing it sequentially, instead of validating all those scenarios, definitely what if we assign each thread to each of the tasks and they are processing it parallelly, and then we can decide the decision will be taken based on the output of all those 5 threads whether the alarm needs to be triggered or not. Instead of using a single thread, we can use a multi-threading there to evaluate the alarm final out final condition whether it needs to be triggered or it does not needs to be triggered. So that is it for this one.